Hello, and welcome to the VERA installation tutorial video. The Versatile Electrode Localization Framework, VERA, is a MATLAB-based tool that was built to simplify the process of localizing ECOG and SEEG electrodes in the MRI coordinate space. This is a crucial step in invasive neurophysiology research, as precise knowledge of the recording locations is critical to interpreting electrophysiological recordings. VERA is an extremely useful tool for reducing the tedium of localizing electrodes manually, with existing integration of a variety of co-registration tools and support for partially automated electrode localization. However, VERA aims to go beyond this, acting as a modular and extendable framework for integrating other tools seamlessly into a processing pipeline, such as introducing a new functional atlas for labeling electrode locations. The result is a profile of a subject capturing all of the details of the electrode localization in one place, along with the results of each processing step in the localization pipeline, ensuring no information can be lost. A MATLAB data structure packaging the segmented brain model, electrode locations, and labels for many atlases used in the processing pipeline can also be produced for further analysis. In this video, we will talk through the steps needed to install VERA on Mac OS and Windows, as well as the necessary dependencies for following our standard electrode localization pipeline. VERA runs on MATLAB 2018b or higher and requires the Image Processing Toolbox, Statistics and Machine Learning Toolbox, and the Computer Vision Toolbox. In addition to these MATLAB toolboxes, the standard pipeline for localizing SEEG electrodes makes use of SPM12 for MRI-CT co-registration, FreeSurfer for brain model segmentation and point set editing, and our in-house report generator tool for producing a PowerPoint report of electrode locations. If you are also interested in localizing ECOG electrodes, the Neuralect tool is useful for projecting the electrode locations onto the surface of the brain model. Make sure to check out the VERA wiki page at github.com/neurotechcenter/vera/wiki to see the currently supported tools list, including Pacer for DBS lead detection. First, we will need to download VERA and the various dependencies. VERA and the report generator are managed through GitHub. If you already have Git installed, you can clone these repositories from our GitHub page, github.com/neurotechcenter. Here you can see the main page for the VERA repository. If you do not have Git, you can download the tools directly from GitHub using the download button. Next, you should download the co-registration tool SPM12 from the University College London website at the link shown here, and the Neuralect tool from the Neuroimaging Tools and Resources Collaboratory website at this link. As FreeSurfer is a tool developed for Unix-based operating systems, you can download and run the tool directly if you have a Mac or Linux machine. Follow the link below to download FreeSurfer on Mac or Linux. It is also important to acquire a FreeSurfer license and copy it to the FreeSurfer installation path. If you would like to use VERA on Windows, you will need to install a Unix shell to run FreeSurfer. For this purpose, we have created a tool called FreeSurfer for Windows, which you can find at the GitHub link below. FreeSurfer for Windows downloads an Ubuntu subsystem and then installs FreeSurfer. Start by opening the README file. This will detail the steps we are about to follow and is a useful reference. Start the tool by selecting Run Me. This will open a Windows PowerShell window that will start downloading an Ubuntu shell to allow us to run Unix-based tools on Windows. When the download is complete, Ubuntu will ask you to create a Unix username and password. Once the account is created, the setup will finish. You can close the Ubuntu window when you reach this step. It is not necessary to update Ubuntu. Once the Ubuntu window is closed, the Windows PowerShell script will continue. You will first select the directory where you would like to store FreeSurfer. The script will then proceed to download the necessary dependencies for Ubuntu. You will need to say yes to upgrade the newly downloaded packages, and yes again when prompted to install more packages. The next step will download FreeSurfer to the mount/c/FreeSurfer directory. This is a fairly large download and will require some time. After FreeSurfer is finished downloading, we will need to extract the compressed file into our desired directory. Enter the password you created for your Ubuntu user. You can check that this step is progressing by opening the path you specified to store FreeSurfer in. In my case, I selected C:/FreeSurfer. When FreeSurfer is finished unpacking, you will need to say yes to add the FreeSurfer path and display setting to the Ubuntu profile. Finally, the PowerShell script will download VCXserve, a tool that allows us to start GUI versions of programs on Unix servers under Windows. This will allow us to open FreeView. Again, enter your Unix password and say yes to the prompt. When this step is finished downloading, the PowerShell script should close automatically. Make sure again to acquire a FreeSurfer license and copy it to the FreeSurfer installation path. It is best practice to always start up Xlaunch before starting VERA on Windows, as any steps involving FreeView will not work properly without Xlaunch running. Start Xlaunch from the desktop icon. Then, keep the default settings of multiple windows and start no client. On the third page, be sure to uncheck Native OpenGL. Click Finish. Please note that you will need to follow this procedure every time you wish to use FreeView, the graphical user interface of FreeSurfer on Windows. FreeView is used as a core step in our standard VERA processing pipeline, so we will need to start Xlaunch every time we wish to use VERA on Windows. Once you have downloaded all of the necessary dependencies, you are ready to run VERA. From this point on, the steps on Windows and Mac should be the same. Simply open the Startup VERA M file in the VERA root directory. Launch VERA by running this tool in MATLAB. You should see the VERA GUI appear with an empty processing pipeline on the left. When we create a new project, this field will be populated with the processing steps defined in our pipeline. Before we can make full use of the tool, we will need to link the dependencies to VERA. The easiest way to link the dependencies to VERA is to create a new project. Simply click File, New Project, then right-click to create a folder for the project, such as VERA_test subject, and say Select Folder. Then select a relevant processing pipeline, such as the simple tutorial pipeline. You should now see a VERA processing pipeline on the left side. The simple processing pipeline contains all of the components necessary to co-register a CT to an MRI image, perform an automated electrode localization, manually verify the electrode locations using FreeView, and create a subject data structure and report. In the next video in this series, we will go through these steps in more detail. You may notice that there are red X's next to each component. VERA components must be configured before they can be run. In this step, VERA checks that all components will have access to all of the data they expect to use. For example, co-registration requires an MRI and CT to be loaded. When configuring the components, VERA also checks that all external software dependencies can be found. Navigate to the drop-down for Configuration and select Configure All Components. This will fail with the warning Unresolved Dependencies. This is because we have not linked VERA to the external software dependencies needed for this pipeline yet. Next, go to Configuration Settings to set the paths to each of the dependencies. This will open a table of all of the external dependencies needed for the selected pipeline. It is important to set the path as the main folder of the tool, not a super or subfolder. If you are using VERA on Windows, the Ubuntu subsystem path should be set to /mnt/. Now when you try to configure all components, the configuration should be successful. Yellow check marks indicate components that are ready to be run, while yellow wrenches require information from other components before they can be run. Here is an example of a completed VERA project. Please see our next video titled VERA Basic Use to learn how to perform an electrode localization. Please be sure to visit our wiki page at github.com/neurotechcenter/vera/wiki for more information about the project. Thank you for watching our VERA installation tutorial video.